Now I want to take a look at how to solve a linear equation, and we're going to focus this time on linear equations that have variables only on one side of the equation. Now we're going to start off by listing a few steps to follow that will get you through these problems, hopefully with minimal difficulties. Now the first thing you want to do when you have a linear equation to solve is to get rid of all fractions. So the first thing you want to do is, if there are any fractions, you're going to want to multiply both sides of the equation by the least common denominator. Using the least common denominator for all the fractions that you see anywhere within the equation will cause all denominators to be eliminated, and you won't have to work with fractions anymore. Now the second thing you do is to use the distributive property. Distributive property will be used whenever you have parentheses or braces or brackets or anything like that that need to be removed. Third thing we want to do is to combine all like terms. Combining like terms means that the properties that you're going to have to use, like multiplication property, addition property, and so on, are going to be used a minimal number of times. The next thing we do is we use the addition property. Anything that needs to be moved from one side to another, that can be moved by addition or subtraction, needs to be moved at this point. Step number 5 is to use the multiplication property. Using the multiplication property should give you the final answer, and of course once you get that final answer, the last thing we always have to do is check the answer. Now, checking the answer, that should always be done in the original equation as it was when you found it, before you made any changes to the equation. And that will prevent any mistakes that you've made during the solving of the equation from tricking you into thinking that you have a correct solution when you really don't. So let's go ahead and jump into some examples of how these equations are to be solved. So here are our examples. All right, first to start off with a fairly easy one. We see basically two operations taking place here. We see multiplication and we see subtraction. Of course, we use inverses to solve, so we're going to use some division and some addition to solve this particular problem. So let's run through the steps that we already outlined. Number 1, in this problem, there are no fractions. Number 2, there are no parentheses, so I will not need to use the distributive property. Number 3, there are no like terms, so we're going to jump straight into using the addition property. The 4 is what has been subtracted, so I will get rid of it by adding. What you add to one side, you have to add to both. This cancels. We have a 2x equaling 12. After using the addition property, we use the multiplication property. Of course, multiplication property allows for division. So I'll divide both sides by 2, and I get my answer of 6. And quickly checking that answer by substitution, I see that I in fact have a correct answer here. Alright, so let's go to another example, one that uses different properties. Let's take a x over 3 plus 7 equaling 11. We have division, we have addition, so we're going to get rid of the division with multiplication. We'll get rid of the addition with subtraction, but in what order? Again, as the rules have outlined, the addition property comes before the multiplication property. So I will subtract 7 from both sides first. And the second thing would be to multiply both sides by 3. 3's cancel. Again, you have a result that can easily be checked. And again, we have a correct answer. So let's go on to working a problem or two that use some of these other properties. Alright, next we have x minus 4 all over 6 equaling 9. Now with a problem like this, when you have an expression like this in the numerator of a fraction, whether the book puts it in there or not, I believe that parentheses are called for. In this particular problem, we have a fraction that we're going to want to get rid of, and so therefore we will start off multiplying both sides by 6 as step number 1 indicated that we should do. Multiply through to get rid of the fractions. The 6 will cancel the 6. We have an x minus 4 equaling a 54. And at this point, to get rid of the minus 4, we're going to want to add 4 to both sides, and we get that x equals 58. Now, I've been checking these by hand. We, of course, can check them on the calculator if we decide to do that. We came up with an answer of 58. Let's see if that's correct. In parentheses, we will put in the 58 minus 4, close the parentheses, divide it by 6, and the result is 9, which is exactly what it was supposed to be. If you remember from the original problem, that was a 9 there to begin with. So again, we have a correct answer. Let's go on to another problem that again uses more properties. Let's look at 7 equaling 8 minus 5, and then in parentheses we have an m plus 3. Now, what we're going to have to do is, again, remember our order of operations. Remember the order in which we're supposed to solve these things. We don't have any fractions. Number 1 is not needed. Number 2 says you use the distributive property, and this time we're going to have to do that. So we have 7 equaling 8 minus, don't be tempted to do 8 minus 5 is 3. Again, subtraction does not come at this point. We now distribute. So this becomes a minus 5m and a minus 15. The next step, after using the distributive property, is the combining of like terms. And again, we can do that. 7 equals, we're going to put the negative 5m up front for convenience, and an 8 and a minus 15 is a minus 7. Now at this point, if you want to trade sides and make it negative 5m minus 7 equals 7, if that's more convenient for you, you can, but you don't have to. I prefer my variables on the left, so that's what I would do. So I would go on to add 7 to both sides. I get negative 5m, because it's negative 7, the minus 7 and the plus 7 cancel, equaling a 14. Dividing by negative 5 on both sides, I have an answer of negative 14 fifths. Now note that you do not always get a nice, clean, perfect integer answer. This time we got a fractional answer, which is a completely acceptable type of answer. Now we need to get into a few problems where fractions really get involved. If we wanted to look at a 4d minus 1 all over 3 equaling 12. Again, remember, you need to put parentheses around those numerators. We're going to multiply to get rid of fractions. Multiply both sides by 3. And the 4d minus 1 comes out, and you've got a 36. Again, the addition property. 4d equals a 37. Dividing by 4 on both sides, you got d equaling 37 fourths. Again, fractional answers are completely acceptable. Now, I want to go on to look at some problems, some fractional problems, where we actually have more than one denominator to deal with. It's easy to cancel out a denominator when there's only one of them, and there's really no question what the LCD will be. So, let's take a look at a couple problems where we have a couple of different denominators. Let's look at x over 3 minus 3x over 4 equaling 1/12. And we have 1, 2, 3 denominators here, and the least common denominator for all three of these would be 12. So that's what we multiply by. We multiply by 12 in 1, 2, 3 places. And we cancel. 12 over 3 is a 4, so this becomes a 4x minus. 12 times 3 is 36. 36 divided by 4 is a 9, so it's a 4x minus a 9x equaling, and when the 12's cancel, we get a 1. Combining like terms, 4 minus 9 is negative 5. And all that's left to do is to divide by negative 5. And we get a negative 1/5 for our result. Alright, let's look at one more example that has some of these fractions in them. Let's look at negative 3/5 equaling a negative 1/9 minus 3/4 x. Of course, 3/4 x is the same thing as 3x over 4. You can write it either way. But we have a 5, we have a 9, and we have a 4. We need to figure out what a least common denominator would be for all of those. There's several different denominators that you could go with, but since they really have nothing in common, they don't have any common factors, it's going to be basically whatever you get when you take the 9, the 5 times the 9 times the 4. So our least common denominator is 180, a rather large one, but shouldn't be a problem. We have our calculator here. So we're going to multiply all the way through by 180. Multiply by 180 in all 1, 2, 3 places. So let's let the calculator help us with these. Clear it out. 180 times 3/5 would be 108. So it's a negative 108 equaling, now for the 1/9. 180 times 1/9 is 20. So it is a negative 20 minus, now for the 3/4 times 180. 3/4 times 180. It's going to come up to be a 135. Okay, so minus a 135x. Alright, so here we go. Solving for x. Add 20 to both sides. And so we have, with the calculator's help, a negative 108 plus 20, which of course is negative 88. Negative 88 equaling a negative 135x. So when I divide by negative 135, the nice thing about this calculator, so I can just say, since I have that already there, I can just say divided by negative 135 is, oh, that's an ugly decimal. Let's let the calculator turn that answer into a fraction, and it's 88 1/35. Actually won't simplify any further, so we get that x equals an 88 over 135. So there are a few examples of how we can solve these linear equations and with one variable on one side using our distributive rule, our combining of like terms, our multiplication property, and our addition property. And again, these steps and the order in which they should be followed, you should memorize and use them enough where that you don't have any trouble using them in the correct order every time.